Question number 11. Sum of the first P, Q and R terms of an AP are A, B and C respectively. Prove that A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q equal to 0. Given sum of the first P, Q and R terms of an AP are A, B and C respectively. Thus, sum of first P terms of an AP is S suffix P equal to A, and sum of first Q terms of an AP, that is S suffix Q equal to B, and sum of first R terms of an AP, S suffix R equal to C. To prove this equation is equal to 0. First step, consider an AP. And assume values for first term, common difference and number of terms. Here we have small a in the equation. So we can assume capital A for first term. So let first term be capital A and common difference be capital D and number of terms be n. And we know that sum of first n terms of an AP, Sn is equal to n by 2 into 2a plus n minus 1 into D. N number of terms, A first term and D common difference. Now, as per question, it's given that SP is equal to A. Sum of first P terms of an AP is equal to A. Now, expand SP by using this equation. SP is P by 2 into 2A plus N minus 1. Here N is equal to P. P minus 1 into common difference equal to A. Same as A is equal to P by 2 into 2A plus P minus 1 into. Here our aim is to prove this equation by using this given relation. Consider the first term. Here we got A is equal to, right? Here we need A by P. So next step, take P to LHS. A by P equal to 1 by 2 into 2A plus P minus 1 into D. Now open the bracket. A by P is equal to 1 by 2 into 2A. 2A by 2 plus 1 by 2 into P minus 1 into D. P minus 1 by 2 into D. 2 and 2 get cancelled. Now A by P is equal to A plus P minus 1 into D. So now we got the value of A by P, and our first term is A by P into Q minus R. So next step, multiply both LHS and RHS with Q minus R. That is A by P into Q minus R equal to A plus P minus 1 by 2 into D into Q minus R. Solve this. Equal to A into Q minus R. Q minus R into A plus P minus 1 by 2 into D into Q minus R. P minus 1 into Q minus R by 2 into D. Mark this as equation number 1. That is, here we got the value of first term of this equation, that is A by P into Q minus R. Now in the same way, find out the value of second and third term by using the given relation. Here second term is B by Q into R minus P. B means you can consider the relation SQ is equal to B. To B means sum of first Q terms of an AP is equal to B. Expand SQ. Here N is equal to Q. So SQ is equal to Q by 2 into 2A plus q minus 1 into d equal to b. Same as b equal to q by 2 into 2a plus q minus 1 into d. Next step, here we need b by q. So take q to LHS. b by q is equal to 1 by 2 into 2a plus q minus 1 into d. Open the bracket. b by q is equal to 1 by 2 into 2a. 2a by 2 plus 1 by 2 into q minus 1 into d. q minus 1 by 2 into d. 2 and 2 get cancelled. That is b by q is equal to a plus q minus 1 into d. So here we got the value of b by q. And our second term is b by q into r minus p. So next step, multiply both LHS and RHS with r minus p. b by q into r minus p is equal to a plus q minus 1 by 2 into d into r minus p. b by q into r minus p is equal to, open the bracket, a into r minus p. r minus p into a plus q minus 1 by 2 into d into r minus p. q minus 1 into r minus p by 2 into d. Now mark it as equation number 2. So here we got the value of the second term also. Now in the same way, find the value of third term. That is c by r into p minus q. For that, consider the third relation SR is equal to c. Sum of r terms expanded, that is r by 2 into 2a plus r minus 1 into d equal to c, same as c equal to r by 2 into 2a plus r minus 1 into d. Here we need c by r. So take r to LHS. That is c by r equal to, multiply with 1 by 2. 2a by 2 is a plus 1 by 2 into r minus 1 into d, r minus 1 by 2 d. Now third term is c by r into p minus q. So multiply both LHS and RHS with p minus q. c by r into p minus q is equal to a plus r minus 1 by 2 into d into p minus q. c by r into p minus q is equal to, open the bracket, a into p minus q. You can write it as p minus q a plus r minus 1 by 2 into d into p minus q, r minus 1 into p minus q by 2 into d. Mark it as equation number 3. Here we got the expansion for those three terms, right? And here question is to prove the sum of these three terms is equal to 0. So next our aim is to add these three terms and prove its sum is equal to 0. Next step, equation 1 plus 2 plus 3. First add all LHS terms together, that is a by p into q minus r plus b by q into r minus p plus c by r into p minus q. Equal to, now add all RHS terms together, q minus r into a plus p minus 1 into q minus r by 2d plus r minus p into a plus q minus 1 into r minus p by 2d plus p minus q into a plus r minus 1 into p minus q by 2d equal to, first take a terms together, q minus r into a plus r minus p into a plus p minus q into a. Let's take d terms together. That is p minus 1 into q minus r by 2 d plus q minus 1 into r minus p by 2 d plus r minus 1 into p minus q by 2 d. Put a bracket. Now, here a is common, take it out. So, this is equal to a into q minus r plus r minus p plus p minus q plus d by 2 is common, take it out. D by 2 into p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q equal to, now solve this, q minus q 0, minus r plus r 0, minus p plus p 0. That is a into 0 plus d by 2 into, now open the bracket, that is p into q minus r minus 1 into q minus r plus q minus 1 into r minus p, that is q into r minus p minus 1 into r minus p plus r minus 1 into p minus q, r into p minus q minus 1 into p minus q equal to a into 0, 0 plus d by 2 into p into q minus r, that is pq minus pr minus 1 into q minus r, that is minus q plus r plus q into r minus p, qr minus pq minus 1 into r minus p, minus r plus p plus r into p minus q, r into p, p same as pr minus r into q same as qr minus 1 into p minus q minus p plus q. Now solve this, pq minus pq 0 minus pr plus pr 0 minus q plus q 0 plus r minus r 0 qr plus qr minus qr 0 plus p minus p equal to 0. So equal to d by 2 into 0, that is equal to 0. Here we proved a by p into q minus r plus b by q into r minus p plus c by r into p minus q is equal to 0. Hence proved.